Next, what we are going to do is we want to add the edges corresponding to the homophily on this network, and we have seen that according to homophily we are going to connect each node to two nodes towards its left and two nodes towards its right. And we have also seen that when we were portraying this network, drawing this network, the nodes were not in any particular order. So for the time being, to test the validity of the code, I will simply change the number of nodes to 6. So we will be having 6 nodes numbered from 0 to 5. And next what I am going to do is I have to add homophily based edges to it. So I call a function add edges g here. So what this function is going to do is add ties based on homophily to this network. And how do I do that? So that is very simple. So what I have to do, I have to connect node 0 to two nodes towards its right, which are 1 and 2, and two nodes towards its left. You can see that those two nodes are not -1 and -2, rather those nodes are this node number 6 here and that node number 5. So how do we do that? So what we can simply do is we obtain a list of so let me define the function here. Define add edges and I pass the graph G here, and what I do is I obtain a list of nodes here. List of nodes equals to G dot nodes, which are simply the list nodes equals to G dot nodes, which are simply the nodes in this graph G, and we can actually print this list nodes and see what it is giving to us. So when I execute this code, we can see that we got here 5 nodes 0, 1, 2, 3, 4, 5. Well and fine. Now what we have to do is, we have to connect each node. So we have to take every element in this list nodes, and every element is to be connected to two elements towards its left and two elements towards its right. So how do we do that is, for each in list nodes, what do I want is, I'll print each, and rather not each in list of nodes, for I, for I in range, so we need indices here. For I in range 0 to length of list nodes, what we are going to print is, we are going to print list nodes I, right? And where this list nodes I should be connected to is list nodes I plus 1, list nodes I minus 1, list nodes I plus 2, and list nodes I minus 2, right? So this thing is very clear. So we have seen previously whenever the indices of a list goes in minus, it starts back from 0. So let's see whether it's working or not. So let's see what is it printing. So you can see here 0 gets connected to 1, 5, 2 and 4. 1 gets connected to 2, 0, 3 and 5. 2 gets connected to 3, 4, 1 and 0. 3 gets connected to 4, 5, 2 and 1. Little bit problem with 4. It gets connected to 5, 3. And then 4 gets connected to 5, and then 3, and then 5, 3, and then 4 plus 2 is 6. Okay, so you note the problem here. So here, when the index of a list, whenever the index of a list goes in minus, there is no problem. It starts off from the last element, but there is no element named as list nodes I plus 2. So what we can do here is little bit of manipulation is required here. So list nodes I we can use, and there can be a little bit problem with this I plus 1 and I plus 2. I minus 1 and I minus 2 are perfectly fine. So with I plus 1 and I plus 2, there is a little bit of problem. So we'll just resolve that. Okay. How do we resolve that? When will I plus 1 cause problem? You can say that I plus 1 will create problem when you go to this element. So the last element of my list will be n minus 1, where n is the number of nodes. The last element is n minus 1, and it will create problem when it has to connect to list nodes of I plus 1, which is n, and there is no list nodes of I plus 1 because the length of the list is total n. So we cannot access this element here. So we can simply put a loop here. So what we are going to do is, whenever our and you can also notice one thing here before doing that, list nodes of I is actually nothing but I, right? List nodes of 0 is 0, list nodes of 1 is 1, and so on. So whenever my list nodes of I plus 2, so whenever I plus 1 has a danger, whenever I plus 1 has a danger of becoming n, whenever I plus 1 has a danger of becoming n, we need to set this value to what will go back from the starting. So whenever it is n, it has to be set back to 0, and whenever I plus 2, it tends to become, okay, it can be n, or whenever I plus 1, or it can also be I plus 2, whenever they tend to become n, we tend to set that value to 0, and whenever these two values, they tend to become n plus 1, we need to set them to 1. So let's quickly see how we can set it. So we know that this node, list nodes I, has to be connected to list nodes I plus 1, I plus 2, I minus 1, and I minus 2. I minus 1 and I minus 2 are perfectly fine. So there can be a problem when we are connecting them to I plus 1 and I plus 2. So what we are going to do is, what we have to actually do is, we have to g dot add edge, and from where to where we have to add edge, list nodes of I to list nodes of I minus 1 can be simply added, and list nodes of I to list nodes of I minus 2 can be simply added. And now what we are going to do is, let's say target equals to list nodes of I plus 1, and what we are going to do is, if target equals to n, what we will do is target equals to 0, and rather okay, and then if target equals to n plus 1, what we are going to do is target equals to 1. We can actually simplify it. So we can write both of these statements as one statement. What can that be? We can write, if target is greater than n minus 1, what we are going to set the target to be? So target is going to be set to, when I write target equals to n minus target. So if target is greater than n minus 1, Now if target is n, it should be set to 0, and if target is n plus 1, it should be set to 1. So target is nothing but target minus n. So can I do target equals to target minus n? What will it do? If target is n, it will set target to 0, and if target is n plus 1, target will be set to 1. Okay. So target equals to list nodes I plus 1, and then this happens, and then what I can simply do is g dot add edge from list nodes I to target, right? And now this target can be list nodes I plus 1, and this target is also going to be list nodes I plus 2. So I am essentially going to replace this whole thing with if target equals to list node of I plus 2, and then this code remains the same, and then g dot add edge list nodes I comma target, right? And then we can comment this statement. Now to see whether this code is working fine or not, what I am going to do here is I am going to look at the neighbors of each nodes. So for each in g dot nodes, I am going to print each comma, and then for each one in g dot neighbor, so I am going to look at all the neighbors of this node, each here, and I am going to print these neighbors one by one, print each one, and then I print a new line here. Let's now execute this code and see. Okay, so we get an error name n is not defined. So we have again and again used n here, and we have not defined what is n. So it's easy. What is n? As we have discussed, n is nothing but the number of nodes in the network. So n is g dot number of nodes. Okay, here is again some problem. Target equals to list nodes I plus 2, line number 16. Okay. So what is going to happen here is when we obtain the target equals to list nodes I plus 1, it is simply throwing us an error here. So what can we do here is remover. So we know that list nodes of I is mainly nothing but I until and unless this value here becomes in negative. So list nodes of I minus 1 needn't be I minus 1. It can go back and start from the last element in the list. But list nodes of I is essentially going to be I. So what I can do here is instead of list nodes of I plus 1, so the maximum index in this list is n. N minus 1. So if it here becomes the value n, so it cannot determine the value for list underscore nodes n. So what I am going to do here is target equals to I plus 1. So if target equals to I plus 1, so now if target is greater than n minus 1, we are going to change the target to target minus n, and then we are going to add the edge. Otherwise, okay. Otherwise, what we are going to do is else g dot add edge. Otherwise, there was no problem, and we can simply add an edge from list nodes of I to target. And similarly here, so what I am going to do here is target equals to I plus 2. And if target is greater than n minus 1, this thing happens. Else, we can simply put an edge from list nodes I to target without changing target. So let us now run this code and see. Okay, so you can see here that we got a graph where 0 is connected to 1, 2 and then back towards 4 and 5. 1 is connected to 2, 3, 0 and 5. 2 is connected to 0, 1, 3, 4. 3 is connected to 1, 4. 3 is connected to 1, 2, 4, 5. 4 is connected to, okay, little bit problem with 4 here. 4 should be connected to 3, 2, 0 and 5, right? Yeah, 4 is connected to 3, 2, 0 and 5, perfectly fine. And 5 should be connected to 2 towards its left, which are 3 and 4, 2 towards its right, which are 0 and 1. So this is perfectly fine. So we have created the homophily based links, and what we can do is we wanted a graph here for 0 to, let's say we want 50 nodes here. So I'll make it 50 here, and then we can execute it and see. It might look here that this graph is okay. You cannot see a complete cycle here, but you can test the edges here and ensure that they all are correct. So you can see that 0 is connected to 1 to 48 and 49. 1 is connected to 2, 3, 0 and 49. 2 is connected to 0, 1, 3, 4. So you can verify all these edges. So verifying all these edges, you can confirm that we are getting a perfect cycle here, where every node is connected to 2 nodes towards its left and 2 nodes towards its right.